combining like terms. When we combine like terms, we look to see what has the same variable and same exponent. If it has the same variable but different exponents, they're not like terms. If it has the same exponent but different variables, they're not like terms. So for number 1, we have 4y plus 5y minus y. We're combined from left to right. We have 4y plus y, which is 9y. Bring everything else down. Now we have 9y minus y, which is 8y. All right, number 2. We have 3z plus 7 minus 6z plus 2. We can see that we have different terms here because some have variables and some are just constants. So I'm starting out with 4 terms, and I'm going to simplify this. I have 3z and a negative 6z. 3 minus 6. I can't do 3 minus 6, so I have to use additive inverse to change this to 3 plus negative 6. I have different signs, so I subtract. 6 minus 3 is 3. The bigger number is negative, so this answer is negative. You keep your variable. I have a positive 7 plus 2. 7 plus 2 is 9. So this is negative 3z plus 9. Number 3. 3a minus 4a plus 6a. Again, we start from left to right. All of my terms have the letter a, the variable a. All of my terms have the same exponent. If there's no exponent there, then the exponent is 1. So I have 3 minus 4. If I have 3 minus 4, I can't take 4 from 3, so I have to change this to addition so I can use my addition rules. Keep your first number, change subtraction to addition, take the opposite of the second number. My signs are different, so I subtract. The bigger number is negative, so my answer is negative. Negative 1a plus 6a. Again, these terms are like terms, so I'm going to combine them. My signs are different, so I subtract. 6 minus 1 is 5. The bigger number is positive, so my answer is positive 5a. Number 4. 4a plus 6a plus 2a squared. I can combine 4a plus 6a because they are like terms. They have the same variable. 4a plus 6a is 10a. Then I have 2a squared. Even though I have the same variable with 10a and 2a squared, I do not have the same exponent, so I cannot combine those. I just write them beside each other. Do not distribute this exponent to the coefficient. This exponent only goes to the variable. If your exponent goes to, you will know that your exponent goes to the coefficient if your term is in parentheses and then the exponent is outside of the parentheses. Then you would use distributive property to distribute it to the coefficient and the variable. But if it's written like this, where it's just right beside the variable, then a, your variable, is the only thing that's squared. Do not distribute that to the coefficient. You will get it wrong. Number 5, x cubed plus 2x squared plus x cubed. I can combine the x cubes. X cubed plus x cubed is 2x cubed. And then I bring down my 2x squared. 2x cubed plus 2x squared. Do not add the two of these together because they have different exponents. You cannot combine those. Number 6, 2x plus 7 plus 5x minus 4 minus x. Circle all of our x terms. 2x plus 5x is 7x. 7x minus x is 6x. Then I have 7 minus 4, which is 3. 6x plus 3.